Hello, hello. Hello, welcome. All right, so this is the Swarms Town Hall meeting. We're going to be um, discussing a couple of things, such as our newest updates, demos for those newest updates. We're also going to have like a Q&A session where you can ask anything. We'll be sharing our roadmap as well and a couple of other fun activities. So I'll start by going over a couple of things that have been going on these past few weeks, new updates that we've added, and etc. Um, let's just wait a couple more minutes for some people to get up in here. Hello, hello. Haven't live streamed in some time because needed to be locked in on shipping some updates, but I do miss it. It is fun, um, and I miss talking with the people. Um, but we've been growing really fast these past couple of weeks. Honestly, like the growth since December has been just ridiculous. Um, I did not think this was going to happen, but everything is good. So you know that's good. Um, yeah. So the first couple of things I want to uh, demonstrate is our Swarms API. So the Swarms API is definitively, um, I'd say, our most simplest product ever. Um, so you can check it out on our documentation. Um, Basically, how it works is like you essentially have like a bunch of agents you can configure, and then it auto selects, or you can choose which swarm architecture you want, and thus you can build any type of multi-agent system that you want. Let me just figure out how to share my screen here. All right, nice. So this is the main docs. If you go to docs.swarms.world and you go to Swarms Cloud, here you can find the docs, overview the Swarms API, et cetera. Gives you some endpoints available, um, gives you some specs, and then this is a sample request using curl. Now, this is basically how it works. So you have a name and a description, just kind of like the swarm name and description, and then you give an array of agents. And so this array of agents can be customized to do as you wish. You can give any name, any description. You can give prompts. You can give very detailed prompts. You could choose over 400, 500 different models. You could choose their role. You can have workers, directors, etc. You can choose the number of loops, which is how many times the agent is talking with itself. You can choose max tokens, temperature. Even you could like auto select the generated prompts. This will autonomously make a prompt for you, so you don't have to do it. Here we have another agent. And yeah, so you can do a bunch of things with these agents. You can customize them as
A bunch of things with these agents you can customize.
You can add tools to them. You can add RAG to them, etc. You can also add loops. So the loops for the swarm is the swarm entirely. You could choose the swarm type, which is basically how the agents communicate. So you could see how they work in our documentation. So we have hierarchical swarm, we have parallel swarm, and you can like you could choose these different architectures. Let me just a sequential architecture processes tasks in a linear sequence. Each agent completes this task before passing the result to the next agent in the chain. This architecture ensures orderly processing and is useful when tasks have dependencies. And there's many different architectures available. And so you could choose like which one you want to use. Let's see, in the API, we have a couple here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 11, 10 or 11. There's a bunch, and you can customize them as you wish. So the agent range one is pretty customizable. You could choose like, which agent talks to which agent by putting in a flow parameter. The flow is the agent name. And then here you have a series of other pre-built workflows. So then we have a couple of other endpoints as well for health and whatnot. You also see the cost for every API request. You could even do a batch. You could do a batch request where you can have multiple swarms running at the same time. And this is an array of the swarm dictionary that I presented earlier. So here you could do like a series of batches, and you can have any number of agents within them. And there's actually a discount. So if you use the batch endpoint, there's actually a 20% discount. So that's also good for you guys. You could even schedule swarm. So you could schedule swarms now. This is a feature that we added in a couple of weeks ago. So you can schedule what time you want the swarm to run. You can cancel it. You can see some models. You can see the swarms available. You can see all of your history through this endpoint. So you can see like how many swarms have you run, etc. And then here we have some examples, but yeah, I'll get into like running some examples now. So let's see examples. Test. So here we could this is how you see the models available. You can see which models you want. We have over 500 different models. So, GPT-4, Anthropic, Gemini, I mean, you could choose. Like, there's no real limitation as to how many you can choose. So we have over 500 different models if you want. You can select any of these. Yeah. And so this is the models endpoint. It's very simple. You do it in a couple of lines of code. And yeah. So here's our test suite. Let's see. So this is what I'd say like what a pretty production grade demo looks like. So this is a very similar swarm to MCS, which is medical coding swarm. So you basically make a series of agents, and then you have super specialized agents with decently sized prompts that will go ahead and analyze this medical data. So this is how it looks like. This is the main payload. So you give it a name, description, agents, series of agents, another agents. Here we have documentation analyzer, so it reviews clinical documentation and identifies relevant conditions. We have role, we have the model name. We should probably switch this to Claude. I want to use Claude. I think this is, yeah, this one might work. Yeah, we'll see if that works. So here we can choose GPT-4 Mini. And yeah, so we have these pretty big prompts here. You are a clinical documentation specialist. Your role is to carefully analyze medical documentation to identify all documented medical conditions, procedures, and relevant clinical factors. Your tasks include, et cetera, et cetera. And these are the prompts. This is what I'd say a decent prompt looks like. This prompt could be better, but these prompts were made by AI. So I would actually strongly consider having I would actually consider having AI make more prompts because like humans are just not really good at making prompts. So yeah, actually what I'm showcasing now was featured on this new blog that I posted. So if you want to check out this blog, which is mostly for healthcare, and using the Swarms API. So this file that I'm demonstrating right now was presented in this blog that I put out 2 days ago. So you could check that out. We also have some more. Where are the diagrams? Are they here? Yeah. So if you want to see the how the swarm architectures work deeply, this is like a. Actually, let me see if I could pull it up. Yeah, so this is like kind of like a much cooler diagram of how different swarms work. So the hierarchical one is very similar to how companies work. So you have this organizational structure, and you have the parallel swarm as well, which is pretty simple. You just give one task, and then multiple agents are executed. Here we have the spreadsheet swarm, which is basically concurrent, but it's being saved to CSV. Sequential is the simplest one, of course. Mixture of agents is a little bit more complicated. So you have different layers, and they're fed to multiple agents. Then they're summarized and aggregated, and then that's the final outputs. And yeah. So over the past couple of days, I put out a lot of blogs. So you should, I'd recommend checking out some of these articles that I published. I published one about like finance and accounting yesterday. So yeah, if you would want to read deeply into these like specific applications, should check these out as well. Yeah. So back to the payload. We give a name, we give a description, right? And then we have a list of agents. This is a list. And then this is the different agent configurations. So you have agent name, description, prompt, model name, etc. Here we customize all the different agents for a very specific task. And so if we go down after the array of agents, we have the max loops. And so the max loops is how many times the swarm is going to run. Here we have the swarm type, which is sequential. So it's the sequential workflow. That means it's one agent goes, second agent goes, third agent goes. And then this is the main task. So analyze the following clinical documentation and provide accurate ICD-10 CM codes For each assigned code, provide the ICD-10 code, the corresponding condition diagnosis, justification from the documentation, etc., etc. And then that's that function. And then here you have the main function. So this is kind of like simulating like clinical documentation, for example. And so if I clean my terminal and I run this, it's going to take a couple of seconds, depending on the swarm architecture. Sequential workflow is by far the longest because they have to process everything individually. But if I were to switch this to, let's say, concurrent, it would be much faster. So, yeah. So now it's running. It's the agents are talking to each other. We're still focused on accelerating the yeah, you see, like if the prompts are really big, the time that it takes to get your response is going to be increased because there's more tokens that need to be computed and processed by the LLM. So the longer the prompts, the longer the task, the longer it's going to take. And so we run this, right? And these are some of the responses. This was sequential, by the way. I'm going to run this again, but with concurrent, and you can see how much more faster it is. So this is us. Okay. Coding validator. Based on the provided the short summary, here's an analysis along with the assigned ICD-10 codes, justification, and rationale. So one, acute exacerbation of chronic syntolic congestive heart. The ICD-10 code is I50.32. Condition diagnosis, acute exacerbations of chronic systolic heart failure. Justification from the documentation. The documentation specifically indicates acute exacerbation of chronic systolic congestive heart failures and gives EF of 35%, indicating severity and confirming chronicity. Code sequencing rationale, this condition would be the principal diagnosis as it was a primary reason for admission and required significant intervention. Two, non-ST elevation, myocardial infarction. The ICD-10 code for that is I21.9. Condition diagnosis, non-ST elevation, myocardial infarction. Yeah. Justification from the documentation. The summary states that the patient held elevated troponin levels consistent with NSTEMI. And it continues going. Yeah, so that was 3 agents. This is mostly for medical tasks, and the reason why ICD-10 coding is a pretty big task that agents can solve very easily is because, so for every disease, I know for sure in America, it could even be worldwide, but the reason why medical coding is so important is because for every disease or condition, there's a ICD-10 code for this. And so you basically need to map a disease into these codes. And this is very important because if you don't know what ICD-10 code a condition has, then you won't be able to get treatment for that condition. And so typically, historically, people have had to have done this. But with agents can do this very easily. It's not really a concern anymore. And so this is like a $500 billion problem that agents can solve right now, and really effectively as well. So I'm going to run it again with concurrent, and we'll see how much more faster it is. It's been about 2-3 seconds. Yeah. So if you wanted to make this run faster, I'd probably recommend making the prompts smaller. Yeah, it was much faster. It also depends what the model you're using, right? So here we're using Claude. If we wanted to use Grok, for example, we could use Grok. Grok could speed this up quite a bit. So we could try doing Grok. I just need to find the model name. Let's see. Grok. Which one is fast? Grok. We could even do DeepSeek. Yeah, this is the one. All right, so nice. We have Grok. We have Grok, and we could try it again. So this one came a little bit faster because it was concurrent, but a pretty big bottleneck is the model being used itself. So here we can use any model, as I mentioned before. We can use Grok, GPT-4, Claude. It doesn't really matter. And if we call it again, we'll see how much more faster it is. And it's pretty fast. Say 1, 2, 3, 4, 5, 6, 7, 8, 9. Much faster than the previous version. Because like if you look at Claude is extremely slow. So, and it's also like it's being run on traditional GPU hardware, but Grok is faster because it's Grok. And actually, so we could even speed this up even more because DeepSeek is computing a lot of these thinking tokens, right? So if we find another model like, let's say, Llama something. Which Llama? All right, I'll choose Gamma because I haven't tried that one. I want to see how fast it is. So DeepSeek is interesting because DeepSeek has to compute all these thinking tokens, right? And so the thinking tokens take up quite a bit of space. So R1 was actually trained by maximizing the number of tokens that could be created at any given point. So while it is fast, it still has to generate a bunch of tokens. And yeah, let's see how much better this one is. Okay, that did not work. All right, so Gamma might be problematic. Let's see. Let's choose Grok Llama 70B. So this is Grok Llama 3 70B and has a context window of 8192. Wow, that was really fast. Wait. Yeah. Yeah, I think this one takes the W. Let's see. Is the analysis of the clinical documentation with the assigned ICD-10 codes, etc., etc. Yep. And so I'd say a big issue that we're trying to fix right now is speeding up the inference time of multi-agent collaboration. I think that's a pretty important problem to solve because transformers are very slow, unfortunately, and so we're doing a lot of things like concurrency, also leveraging concurrent asynchrony. We're just optimizing a bunch of stuff on the back ends, like removing anything wasteful, and just generally trying to make it as fast as humanly possible. Because if you wanted to run like a million agents in parallel, I mean, it would still probably take about 10 seconds. But like how do we cut that down as much as possible? Like how can we theoretically optimize multi-agent inference to the point where it's not really bottlenecked by the call to the API provider? And so that's a pretty like important problem that we're trying to solve now. And yeah, so another cool thing that we built is the enterprise observability platform. So you can see all your API requests on this platform, and you could even build your swarms in a no code fashion. So it's basically just a form, and then you build your agents. We also have some templates as well, and you can save your swarm, run your swarm. We have agents here, so you can just build your agents and then reuse them. Like you could basically do something like you could have it auto generate the system prompts. So expert and ETFs. You can choose the role, number of loops, max tokens. Boom. And now you could reuse this agent in your swarms. So here you can just put that, and now this agent is in your swarm. So, and then you could build your swarm here, like say ETF, financial swarm. And then if you see here, like you could customize this as you wish. So the description here is basically just like a reminder. So you could say something like provides counsel on ETF management. And then here's where you would give it the main task. So you could say like, what are the best 10 ETFs for short term liquidity? What are the 10 best ETFs that can be exited quickly but provide decent returns? Or something of this capacity. And yeah, so then you could you build the swarm in a no code fashion, and then you also have the code here to put this into your own application. You could do Python, Node.js, and also Rust. So you could also use this in any language. But yeah, we do have some pre-built templates here. So anything you do here, anything you do there will be here as well. So you could copy this code and run it on your own client side. And yeah, so we also have a history, which are the different swarm architecture you have. This is unique swarm. So if you run the swarm 50 times, you'll still only see this one. So I've run this one multiple times. It's just only one. It's I ran one swarm 15 times. And so yeah, we have some settings here. We have some swarm types. You can see some settings, platform settings. This is the white version. This is the dark version, which I like. We also have a pricing page as well, so you can see the pricing. So the way that the pricing for the API functions is you pay $2 for 1 million input tokens for each agent, and then it's $4 for 1 million output tokens, and then you add those together, and then you multiply that by the number of agents. But for our international users, which is from 8 p.m. California time to 6 a.m. California time, there is a 75% discount. So, if you're from Asia or Europe, you can benefit from these discounts quite dramatically. And here we also have like a little calculator you could try to calculate your costs. And yeah, some FAQ as well. So this is like our enterprise platform for the people that want to like, like if you wanted to observe your API executions and things like that, you could see everything here. And then we also have like a easy button to get your keys here. And yeah, so this is back in the marketplace. We've made a lot of significant updates to the search. So the search is much better now here as well. We're going to be integrating payments into the marketplace pretty soon. So you'll be able to, let's say, add a prompt, right? Let's say you want to sell a prompt. You'll be able to, if you wanted to make a prompt that people could actually buy, you could set a price here on somewhere on the bottom, and you could choose how much you want people to buy it for, or an agent or a tool, and prompts, agents, or tools. And so you could, build your prompt here and then sell it to other people and generate revenue from that. We're only going to take a 2% fee out of all transactions. So it'll be, pretty straightforward. You'll be able to put your prompt here, sell it, make a bunch of money. And yeah, so the goal of the marketplace is to integrate payments soon and increase the number of agents here as much as possible and the number of prompts. So if you have any prompts or any tools or agents you want to share, please share them. Other people will find them and start using them. And pretty soon we're gonna start tying in actual money so that you could, buy or sell prompts, tools, and agents. So we've been working on this for quite some time, but we're just trying to make it reliable and secure. We don't want anything bad to happen. So yeah, that's coming soon. Very excited for that. So yep. So yeah, that's the marketplace. We got a bunch of agents here. And we also have a new trending section. This is a preview of our upcoming no-code platform. So we've been testing this quite a bit. It'll be essentially like no-code chat interface for multiple agents. And here you can configure your different agents. So you could, choose whatever swarm type you want. Choose the name, description, number of loops, and then here you could build your agents. It's just a form. And then you could also choose from your pre-existing agents. Or you could even choose prompts from the marketplace. So, you could choose this prompts. And so you'll be able to build the agents in your chat very quickly, very reliably. You could choose this agents or prompts from the marketplace. So yeah. We're still working on this, but we'll be making an announcement pretty soon when it's ready for announcement. There's still some things we're trying to fix, but yeah, every day we're making progress on this. So we have the spreadsheet swarm, drag and drop swarm, and yeah. Also, you could pay for your Swarms API requests with Swarms tokens. So here, if you fill up your balance, you could actually fill up your balance instead of using dollars with the Swarms token. So you could fill up your balance instead of using dollars with the Swarms token. So yeah, that's pretty simple. And once you do that, then you can start sending your API requests as you were before. So yeah, can't wait to share more about the chat interface with you pretty soon. We're still like making some optimizations and try to speed things up quite a bit. So yeah, I'm very excited for that. Let's see what else. All right. I'm gonna stop sharing my screen and answer some questions. So let's see. What questions do we got? You want to learn how to build those agents? Yes. I've put out a very simple blog that shows you how to do this. So you could take a look at this. You can take a look at this and start step by step there. It's pretty simple. First, I'd say download Cursor, right? You need Cursor. And then you just follow this blog and go from there. Yes. The thing is about Cursor is that so a lot of people try building prompts, but I think I think building prompts, especially by our own designs, is very difficult. I would not recommend humans build prompts. I would recommend giving a description of a prompt that you want to make to another agent, and then having that agent actually build the prompt for you. And generally speaking, that's a much faster process than just having to write out the prompts as it is, which would take around like 30 minutes to an hour, especially if you're a good prompt designer. If you're not a good prompt designer, that might even take much more time. And so automatic prompt generation and design and optimization is immensely important. I think it is the future of all agent engineering, if you will. It's also called like meta prompt engineering. There's a really good prompting guide on this. It's called promptingguide.ai. So automatic prompt engineer proposes automatic prompt engineer framework for automatic instruction generation and selection. The instruction generation problem is framed as a natural language synthesis addressed as a black box optimization problem using LLMs to generate and search over candidate solutions. So that's one way. Another way is called meta prompting, where you essentially give a description of a task that you want to complete, and then the agent will build its own prompt to solve this problem. So, and the reason by doing this is that we don't know exactly what is the best possible prompt to solve a task. Like when people use just like ChatGPT or something, this is like, and you just say do this. That's not really efficient because the model has been trained over trillions of tokens, and so it's seen a lot of information. And so the more vague that you are, and the more that you do not specialize these models, the worse the outputs will be. And this is not good. So the more you specialize the model, the better it'll be in terms of generating the outputs that you actually want. So that's pretty important. Let's see. Nice. All right. So from the Swarms API now, I'll go over to just the main core Swarms GitHub framework. Let me share my screen. So we've been accelerating, just optimizing a bunch of things here quite a lot. We've also made some examples using some external agent providers, such as browser use. This one is decently popular now. So I want to show you something pretty sick. So this is pretty simple. This is like 34 lines of code. And here we build a simple abstraction so that you can integrate any agent from any provider in Swarms if you have a class. So this is a class with a run method. So here we're gonna, here we put in the main logic to run the agents. And if I press run, we'll have 3 browser agents that pop up. And they'll all be working concurrently. So if I do this, we'll see them pop up. Boom. And now all these different agents are working together. Well, not together. They're working asynchronously. So yeah. So you can now have like asynchronous. You can even have like 50 of these, like all running at the same time. I could bump it up to 10 or something and show you how it works, but it's pretty simple. It's like almost 40 lines of code. So look at that. I asked it. What did I ask it? Please find the best stocks on Yahoo Finance and summarize their key metrics and potential for investments. Yeah, so it works pretty well. I'm canceling the agents for now, and I'm gonna bump it up to 10. So we'll see 10 agents all running on their own browser instance working together. So this is pretty cool because you can integrate any agents into Swarms. It's not really limited by like, yeah, look at this. Yeah, so there's 10 of them. I don't know what's going on with these two, but these seem to be working pretty fine as well. So this one got the task right, found the top gainers. If I click this, you'll see. Oh wait, no, it didn't find the top gainers. This one did find the top gainers. I'm not gonna press it. I'm not pressing anything. You see? Look at this. It's just doing things. Yeah, so I try to not manipulate with the browser instance. But yeah, so you can integrate any agent into Swarms. I think browser use is pretty fun because you could just run a bunch of browser agents concurrently, and I think that's really fun. We're probably going to make another architecture where you can have So you can give, let's say you have 10 agents, right? You have 10 agents, and you can give each of those 10 agents different tasks. We have a diagram of this in our documentation. Where is this? Let's see. Let's see. Oh, I think it's here. No, nope, not that one. Not this one. Nope. No, it's not there. Where is it? Oh, it's here. I remember. So there are swarm architectures where you can give, like, there it is, grid. So for every task, you can have multiple different tasks, and then you can assign all these different agents different tasks. So say one agent, like find me the best stocks. Agent number 2 can find me the best restaurant in Miami. Agent 3 can, look up the weather. Agent 4 can, I don't know, say find crypto coins. We can actually try that now with Pump.Fun. I'd be very curious to see if that would work. I think they do have a browser like browser security stuff. Oh wait, there's 10 of them. Let me bump that down. So let's observe. What are they doing? I'm very curious to see if they'll get hits by any like anti-bot detection stuff. Yeah, I think it makes you sign in. That's a bit of a problem now, but let's see what these agents do. Will they sign in? Oh, another one bites the dust. Another one bites the dust. Yeah. So if I said, make an account or try making an account, let's see. Let's see what they do. I'm ready to pump. Oh, it hit the privacy notice. Why? Log in. If I said make a coin, it would probably make a coin. I'm not gonna say it to do that, but it could definitely do that if you instructed it, right? So you would have to give it like precise instructions, something like this. Let's just say make an account, use email, and then here you say make a coin. Make a coin called something. Make a coin and give it a cool description and etc. Fill in the form. Sit back. Sit back and watch the coin grow in value. I'm not gonna do this, but I mean, hey, if you want to do this, you definitely can. I don't judge people. I love my Swarm coin. Swarm's coin is my favorite. So If you want to make your own coin, you could, definitely do that if you wanted. But this is an example of like a pretty cool demo where you can like, leverage browser agents and swarms. It's very simple. Okay, I cannot express just how simple this is. This is like, how many lines of code is this? This is like not even, this is less than 20 lines of code if we compacted it together, excluding the prompts. The prompt is taking up some space. But yeah, you could definitely like, you can definitely like customize this as you wish. You can give the agents a system prompt. If you want to do very complicated browser operations, I would say you have to like customize the agent. You have to give it a system prompt, specialize it for a specific domain or website or platform. But yeah, I definitely think that if you customize it, it would be really good. And you can also even have like the agents trading for you. So yeah, browser agents are pretty fun, and Swarms makes it very easy to deploy some of these browser agents. And so yeah, that's like this demo is actually on our marketplace. So if you go to swarms.world and you look up browser and you click this, the code for this example is right here. So you could just copy this. You can copy this code and just run it. So yeah. Another thing I want to demonstrate is that we are progressing in the scale of agent-to-agent communication, and we're scaling in the number of agents that can communicate. So last week we released this new structure called hybrid hierarchical cluster swarm. And so basically what the swarm does is, so let's say, so a swarm, I would consider a swarm to be a team from anywhere from 2 to 8 or 10 agents. And so within a hybrid, I'm going to just say HHCS. So in this type of swarm, you give it multiple swarms, and then you give it a task, and then it'll find the best swarm for the input task. And I'll show you a demonstration in a couple of seconds. So you give it an input. Let's say you have a legal swarm, right? And you want to get a patent or something. You want to make a contract. You give it this input, and then there is an agent that is going to route your input task to a series of swarms. And so you have a task, there's a router. Then the router is going to route your task to the most optimal agents or swarm. And so now you have multiple swarms, and then this router agent is going to route your task to whatever swarm is most optimized for that problem. And I can give you a demonstration now. So this is an example file that's in the Swarms GitHub. And here you can see we have a bunch of agents. And in here we have a bunch of swarms. So these swarms have 2 to 3 agents. This one has 3 agents. This one has 2 agents. This one has 2 agents. This one has 2 agents. This one has 4 agents. This one has 3 agents. And so this is how like you basically build your swarms. And once you have multiple swarms, then you could use the hybrid hierarchical swarm to find the best possible swarm for a given task. So we have name, description, and then we give it a list of swarms, which we defined here. And then you give it a number of loops, and then you could also choose the router model name. So here we're using GPT-4 Mini. And so here we say, what is the best way to file for a pen for AI? Please provide platforms to make it easy to file for a patent. You can also say, and their website links. Then you could also say format this prompt, make it better. So if I run this, we'll see, oh, we have an error. What is the error? Optimize. Oh, I see. I was updating stuff locally. I gotta fix something really quick. All right, where's this? Where's this? All right, let's run that again and see if it works. Nope. All right. That should work now. What is the error? If tools is not non-return. I see. Let's try something. Same error. All right. Let me get down to the bottom of this. Should have pushed this updates sooner. So this is a reason why it's not working is because there was I was making a bunch of changes locally. So the error suggested that. All right, let me debug this. I mean, it's outputting, it's just not being formatted correctly. I see. Raise the error if all retries fail. Yeah, so it's generating, it's just not being parsed correctly. Oh. I think I know the issue. Let us see. No. So it's a string. but it's generating. So now we will try this. Hmm. Hmm. Print type response. Hmm. So the error is coming from here. Raise JSON to go. Hmm. Let me. All right, let me just try something real quick. All right. So that's not the issue. The issue is in here. Could it be the model name? All right, I'm just gonna split this up into another function. So def converts. Do this. Do that. And then here, we're gonna do something like that. Then we're gonna do one print, two prints, and then try it again. Gonna run this and see the output type. Hmm. Output. I know the issue. I see now. I made some changes to the output response. So if I do this, fine. It should be fixed. Yes. That was the issue. Output type final. Now it should function as expected. What is the issue? So from swarms details, where is this? String to dict or JSON. Say now. Oh. Wrong file. What is this taking? But why is this failing? This is perfect output. Yeah, I don't know why this is happening. But we're gonna fix it. This is quite abnormal. Oh, I see the issue. Hmm. Output minus out. Yeah. Let us see. I think that did the trick. Hmm. Hmm. That is what's causing the issue. All right, hold on. Give me just 1 second. All right, so I'm gonna fix that issue now, but it's not in production, so nothing to worry about. I just I was changing a bunch of things locally and making some changes. So I'm gonna fix that, and a couple of things upcoming on our roadmap is the Swarms chat interface. Let me share my screen. Let me share my screen. Yep. So we're going to be launching the chat interface sometime this week. It's going to radically make multi-agent collaboration simple to use. So it'll be super easy to use. You know, you'll just talk. This will mostly be for the non-developers. Excuse me. So this will be for the non-developers. You'll just be able to chat with it, and it'll be super easy. It'll be like using any chat like interface, but there's multiple agents, and you can customize them, give them tools. They'll have memory, etc. It's going to be fast as hell. It's going to be amazing. I'm very excited for this. And if you have the link, you could try it out. You know, there's nothing stopping you from trying out. We just haven't like officially announced it. So yeah, this will be available pretty soon. And another thing that we're working on is in order to eliminate some of these inference speed issues, we've started very heavily working on these Swarms Rust implementations. So Swarms Rust is growing pretty fast. We already have graph workflow, we have sequential, and we have concurrent. We're going to be implementing more and more of these different architectures as time goes on. And I honestly think Rust is the future. Rust is incredibly fast. It's incredibly concurrent. And Python is not concurrent. Python is not fast because the way that Python works is it's single threaded. It has this thing called a GIL lock. And so within this GIL lock, there's not many actions. Like you'd only really have one thread running on this GIL lock at a time. And that's a problem. So we can bypass this issue pretty easily by using Rust or any concurrent language. So if you want to help contribute to this, we have a pretty large bounty pool right now. We have over $200,000 in bounties. So if you want to contribute, we're looking for Rust engineers to help build swarms in Rust. As I mentioned before, I think this is the future. It's going to be fast as hell. It's going to be super high performance. It's going to be amazing. Honestly, I think Rust is the future of high performance agentic systems. Python is simple to use, but it's just not. It's not as high performance as Rust is. So yeah, we're going to be translating everything from Python into Rust. And then from the Python front end, we'll call the Rust backend, and then it'll execute. So that's essentially how we're gonna be doing this, and it's gonna be fast. So I'm really excited for this. Yeah. So if you want to work on this, let me know. Join the Discord. I'll send this in the Discord chat now, so you can get access to it. And yeah, so chat interface, Rust implementation, marketplace, buy and sell functionality. Those are three things coming up. What else is coming up? Oh, we're going to be adding our vast array of reasoning agents into the API as well. So we built a pretty popular state-of-the-art reasoning agents whose sole purpose is to reason and be very hyper intelligence. We were the original implementers of Tree of Thoughts. This blew up. It has 4,500 stars. It took a long time for Swarms to beat this, but as you see, it was like 2 years ago. um, 2 years ago, we implemented Tree of Thoughts, and we're continuing on with our reasoning agents. So we have self-consistency agent, which is directly mentioned in the Tree of Thoughts paper. We have iterative, reflective expansion agents, which is a little bit more complicated. We have a reasoning dual, which is where you take a reasoning model like R1 and then you send its output to a normal model like GPT-4 or Claude. And it basically acts as kind of like R1. So when you use ChatGPT like O3 or something, basically what happens is a thinking model whose sole purpose is to think is going to give the initial input, and then for the output, then the final agent gives the report or the summary. And then we have a router for all these different agents as well. So we have a bunch of different agents for just for reasoning here. And we also have JKP agents, generated knowledge prompting agents. This is something that we added in last week. And basically how it works is you give a prompt, you give an input, and then it'll generate a series of knowledge items. So it'll generate its own knowledge items, and then it'll give you the final output. And so this is actually came from a paper here. Yeah, and so this reasoning agent came from this paper. You can see using a similarity can also be used to generate knowledge before making a prediction. Yeah, so basically how it works is it generates its own knowledge base. So you give it a problem, and it starts generating its own knowledge, which is really cool, especially for like a little bit more difficult task. Then we have agent as a judge. So agent as a judge is kind of like an evaluator for agent outputs. And so you have one agent generate something, then the agent judge will analyze the first agent's outputs, and then it'll give feedback or instruct it to do it better. It's kind of like what humans do when they talk with ChatGPT. They'll be like, "Hey, this is dumb. Make this better." And yeah, that's kind of how the agent judge works. The purpose of the agent judge is to de-hallucinate whatever agent that you're using. And so this is very good just to make the entire agent pipeline much more reliable and give you the outputs that you want. So we're going to be adding in all these different agents that I just talked about into the Swarms API, and we're going to be adding that soon. We're also integrating RAG into the API, and we're integrating HHCS as well as some other multi-agent structures as well. So all those different agents and multi-agent structures will be in the Swarms API. And yeah, so that's what's coming up in the future. Very, very exciting stuff. And we're also starting to look at more no-code interfaces, like games as well. Like how do you build like a game where you could build like fully autonomous, like a fully autonomous agent company, and then watch it, grow in real time. I think that'll be pretty fun. So if you're a game developer and you want to help build games that are not really games, but have like agents doing real things in those environments, hit me up. We have a couple of games that we're trying to make. So yeah, that'll be fun. All right, now I'm going to get into the Q&A section. So if you have any, questions, let me know. And One thing to keep in mind is production grade agents, something that could go to production with little or no customization. Reliable, deployable, secure, configurable without heavy engineering, and cost efficient. I can't think of any framework going this far so far. I think the Swarms API is a testament to this, because you don't really have to do much. You just you give it a prompt. Actually, you don't even need to give it a prompt. It can make its own prompts. And so I think yeah. So I think the Swarms API is an embodiment of what you said. Um, but the thing is, like, I think all frameworks, like, if you have to run them locally, you have to set up the developer environment. You have to put your API keys. You have to, like, just test everything again and again and again. And I think the development experience is what's annoying people, because there's a lot of friction, right? Like, you have to set up your API keys. You have to set up your VMV. It's just a complete and utter mess. And then you actually get to running the code, and then there's, like, small things you need to fix, and yeah. That's why I'm personally very bullish on the Swarms API. I think it's probably the best thing we've ever made, because of how easy it is to use. Now we're still, making it better. We're still optimizing it, still trying to make it faster, more concurrent, more asynchronous where we can, and try to remove as many bottlenecks as possible. But I think, like, moving forward, I think the API is going to become um, an increasingly larger is going to play an increasingly larger part in building these extremely reliable multi-agent systems in production. Yeah. So yeah, and I forgot to mention a couple of things. Let me get my screen back up here. So alongside the Swarms API, we've launched two programs. The first one is the Swarm Startup Program. So this is our program where, if you're building with Swarms and you're building a multi-agent application, it could be like if you're deploying a multi-agent application to your users, or if you're deploying agents inside of your own company for internal operations. We can help give you support, technical support, go-to-market support, and a bunch more. So yeah, we provide, like, technical support. We can help you go to market. We can give you a dedicated account manager. We can give you up to $10,000 in Swarms credits, and yeah. So we have different tiers as well. So if you're a young startup, we can give you 2,500 Swarms credits. We can give you, like, a bunch of resources as well. And for the best startups using Swarms, we'll actually even consider maybe investing in. So if a startup has been using Swarms a lot, and they're doing pretty good, we'll personally consider investing in them in equity. So yeah, we provide a vast array of different support options as well. We can help you with architecture. We can help you with integration. We can help you with optimizing the performance of the Swarm. We could host, technical hours where we analyze some of the code and provide guidance and show you how to optimize it, and a bunch more. So you can find this if you go to Swarms.ai program/startups, and you go to startup program. And then we also have a research program as well for researchers. So if you're doing research for multi-agent research, multi-agent collaboration research, we want to sponsor you as best as we can. We have, grants. We can provide support, also technical support as well. we built the first ever list of multi-agent research papers. So we've been keeping in track with all multi-agent research, and now we have over 20 researchers using in this program. So we have almost 11 now, just from Stanford, and the rest are from a bunch of different colleges throughout the U.S. and China. So if you want to, do multi-agent research, we can definitely provide you with the resources you want, and try to make it. You as a researcher, you should only really be focused on doing research that, like actually doing new things. You shouldn't have to do old things like, paying for credits, setting up API keys. That's a waste of time. You should just be, invested in trying new things and experimenting. And so we can, help you with that and try to automate as much of that as possible. And yeah. So yeah, let us know, what type of support you would like, technical support, integration support, research support. We're here for you. Eduardo says, amazing framework. Thank you. I appreciate that. We're trying to be the best. All right, guys. If there's more people have more questions, you can find mostly everything on, if you go to our website, swarms.ai. So yeah, let me know if anybody has any more questions. Otherwise, I'm gonna probably wrap this up so I can push out a couple of more updates, fix some bugs, and build some new swarms. So all right, well, have an amazing Saturday, everyone. We'll be doing the next one next week on Saturday at 2:30 California time. Well, actually, next Saturday I'll be in Hong Kong. So if you're in Hong Kong or in China or nearby, come on down. We're going to be speaking at the Build 2025 event, which is a humongous crypto conference. So if you're in Hong Kong or nearby, you should definitely come out and visit. This will be actually the first time that I leave the United States forever. I've never left the US, so it's probably going to be crazy. But I'm very excited to come to Asia. So yeah, you could check out what events we're hosting if you go to our calendar. I'll put my calendar link here. So it's lu.ma/swarms_calendar. Yeah. So you could see like what events we're doing this upcoming week. I'll be going to Hong Kong on April 1st. So yeah, it's going to be crazy. I think I'm speaking with Justin Sun, the founder of Tron. We might be on the same panel or something. I'm not sure, but I think that's the case. So yeah, that's going to be crazy. I'm very excited for Hong Kong. I cannot wait, honestly. It's a lot. People have been telling me to come out for some time now, and I didn't have my stupid passport. It takes so long to get a passport in America. It's so dumb. So dumb. We just need to
So you're
automate.
gonna.
We need to automate the entire USPS. Those people should be automated.
I heard Hong Kong is fire.
Yo, what's up, Walker?
Not much.
Yo, Hong Kong, bro.
Just,
Man, Hong Kong is crazy. But
yeah.
I've heard a lot of good things about the food. People say the food there is amazing. So, well,
Okay.
we gotta try it out. You should come, bro.
No, I can't.
Come to China.
gotta make some money.
We gotta go to China, bro. China's where
That's
it's
a good
at.
idea.
What?
Are you here in Florida right now?
No, I'm in California right now.
California. Okay.
Palo Alto.
So you spend like all year, entire year over there.
Me, I mean, maybe, man. I don't know.
Mm.
I'll be in. First I'm going to Hong Kong, then I'm going to China, mainland China. I'm going to Shenzhen, Guangzhou, maybe Shanghai, Beijing, and then when I've traversed China, then I'm going to Singapore, and then after Singapore, where am I going? Probably back to America after Singapore. But,
oh man, that sounds exciting. Good luck to you, bro.
Bro, it's gonna be crazy, man.
Yeah.
America's such a simple place, but Asia is a little bit more unique and interesting.
Yeah.
So, yeah. But after that, I think I'll be spending most of my time this year in California. It's just very good for business, you know. I'd much rather be in Miami, but the thing is with Miami, it's very hard to build a $1 billion business in Miami. It's very unfortunate, but it does have a very good quality of life. You know, everybody in Miami is somewhat happy. Things are pretty cheap. You know, there's no crime, no homeless people. Like whereas California is the complete opposite, right? Like, but it's very good for business. California is a very like dysfunctional, functional place. Like it's like I don't know, it's just not very functional. It's like 50-50.
50-50.
Yeah.
So okay. Man, I've never been to Palo Alto, man. I need to go over there.
Yeah, bro.
Yeah, one of my friends want to go to the event that's gonna happen maybe by the end of the year. Maybe I can go. I can tag along to the startup events.
Mm-hmm.
I forgot the name, but we might go over there.
Yeah, bro. Let me know.
Yeah, bro. I'll let you know.
You should definitely. I think it's like I think if you're an ambitious person, if you want to do like ambitious things in life, I think this is definitely the place. Even though it's very dysfunctional.
Yeah.
Dude, like if you go to China, bro, if you do any form of crime in China, you're like going to jail for life. Like you're never getting out.
That's crazy.
So yeah, California is not like that, my friend. Yeah, I mean you could do anything here. Anything. It's very sad. But yeah. All right, guys. Have a good one. We'll talk soon. I'll probably be shipping an update probably today or tomorrow for the like the core framework. So stay tuned for that, and we'll talk soon. Thanks for